back to another Daishinfinity video. In this video we're going to talk about the Taylor series. Using the Taylor series we're going to prove the derivative of ln of x, that the derivative of ln of x is equal to 1 over x, which is a very fascinating equation in mathematics because it also talks about the harmonic series and so on. Now, if we would want to prove this formula, I would have to derive the definition of the derivative, which states that the derivative of f of x is the same thing as the limit as h approaches 0 of f of x plus h minus f of x divided by h, which is also equal to the prime of f prime of x. Now, if we let f of x equal ln of x, we're just going to take the derivative of it, so d dx of ln of x, which would actually equal the limit as h approaches 0 of ln of x plus h minus ln of x divided by h. Now, using the difference of sum formula, log of a minus log of b is equal to log of a minus b, where b isn't equal to 0. And, b is also greater than 0, you see. A is also greater than 0. Now, you see these two things. Well, you see here, because of x plus h and x, we can write it like this. So we have the ln of x plus h divided by x over h. Now, if we would sum up make it in equal parts, 1 plus x plus h plus x divided by h. Now, since we have a complex fraction h divided by x, I'm just going to call or substitute another variable for the limit. So let's just substitute h over x is equal to t, which would mean that h is equal to t times x. Now, if h approaches 0, t also have to approach 0, which means we would have a new limit as t approaches 0 of ln 1 plus t, and the h would be the t times x. And now we have a new property that the x is independent of h, so we can take the x outside the limit, which we'll do in a short time. I'll just put 1 over x over here so that I will show you that I just brought the 1 over x outside the whole fraction. And because the 1 over x the limit treats 1 over x like a constant, we can put it outside the limit. So we would have 1 over x times the limit as t approaches 0 of ln of 1 plus t divided by t. Now let's continue. Ln of 1 plus t is also known as the infinite sum as n approaches 1, n is going from 1 to infinity of t to the n divided by n times negative 1 to the n plus 1. Now, since we have this sigma, we can also use it in order to just represent this as a infinite sum. So t minus t to the second power over 2 plus t to the third power over 3 minus t to the fourth power over 4, and so on forever. This is the infinite sum of ln of 1 plus t. The infinite sum is actually derived from the derivative of ln of x, or let's say ln of t, for example. So this is not a very good proof to say. It's not even a proof, but I just came up with this type of proven things, so I'm very proud of it. So I just wanted to show you using the sigma notation. Okay, now we see that this is also ln of 1 plus t, so we can also divide by t on both sides so that we get the full expression we need for the limit. Now, if we divide here t and t, this will cancel out to be 1, so 1, and the t to the second will be t to the first, t to the third will be t to the second, and t to the fourth will be t to the third. So all the exponents will downgrade by 1. So we would get t divided by 2 plus t squared over 3 minus t cubed over 4, and so on. This is the same thing as ln of 1 plus t divided by t. So if we would take the limit of this whole expression, we would get 1 plus x, 1 over x, I'm sorry, times the limit as t approaches 0 of t minus t square over 3 plus t cubed over 4 and so on. Sorry, 1 minus t over 2 plus t. I'm not sure if it's a plus or minus. Let me see. Yes, it's correct. So over here this is going to be a minus. So minus plus minus plus minus minus. And now if you would take t equaling 0, this will go to 0, this will go to 0, this would go to 0 and 0 and 0 and 0 and so on forever. So that only the 1 will exist, which would mean the limit as t approaches 0 of 1, which is just equal to 1, the constant itself. So since we have only the 1 times something is the something itself, so we have 1 over x, which would mean that we have proven the formula that the derivative of ln of x is equal to 1 over x. I hope you liked this video. Please like and subscribe to my channel, and we'll see us in the next Daishinfinity video. See ya!